We have completed steps 1, 2, and 3. So we have a relation in terms of theta and z, the two variables, which are functions of time, and a relation between the rates dz dt and d theta dt. Now in step 4, all we have to do, plug in the value of sine theta, the value of d theta dt, and the value of z at the moment we want to calculate dz dt. dz dt is the unknown. Let's look at the question one more time. How fast is the distance between the ant and the point P changing when the distance is equal to 3 inches? So that means find dz dt when z is 3. So we plug in 3 for z here. To plug in the value of sine theta, we can use this relation where z is 3. We find cosine and then use it to find sine. And we can also figure out d theta dt by knowing the rate at which the ant is moving. So let's start with finding sine theta. Let's get this relation. Z squared equals 10 minus 6 cosine theta. Plug in z equal to 3 and then solve for cosine theta. Subtract 10 and then divide by minus 6. Now we can use this most important identity in trigonometry. Sine squared theta plus cosine squared theta equals 1. So cosine theta is 1/6. We plug it in here and then subtract the square of that from both sides. And then take the square root of both sides. You get sine theta equals to plus or minus this expression. After you simplify, you get plus or minus square root of 35/6. Now let's see why the minus is not appropriate here. Look at the picture one more time. Z is 3 at the moment we want to calculate its rate. So that means this ant is about here. So this distance is 3. That makes this triangle an isosceles triangle. So the angle theta is less than 90 degrees. Therefore, its sine has to be positive. So sine theta is positive square root of 35/6. Now let's see why d theta dt is plus or minus 1.4 radians per second. Look at the picture one more time. This is a circle of radius 1. In a circle of radius 1, the radian measure of an angle is equal to the length of the arc in front of it. So the rate of change of that arc is exactly the same as the rate of change of the angle in radians per second. So because the rate of change of the arc is 1.4 inches per second, the rate of change of theta would be 1.4 radians per second. Now plus or minus indicates that the object or the ant can be moving this way or the other way. So now we have the 3 quantities that we need to plug in. We have the z, sine theta, and d theta dt. We can plug them into this relation and then get dz dt. But first we divide both sides by 2 to simplify it. We get this. Now we plug in the z, sine theta, and then d theta dt. Divide both sides by 3, simplify, and approximately the value of dz dt is plus or minus 1.38 inches per second. So at the moment, the distance between the ant and the point P is 3 inches. That distance is changing at this rate, 1.38 inches per second approximately. This completes the solution to problem 3.